Okay, here's the homework problem you guys had, and apparently there was quite a few questions associated with it. So I thought I'd do it and show you how to go about it. Okay, the first thing, it's 2.6a in your book, so if you want to look at it. First thing was I had several people ask me about the labeling. I corresponded back, but these kind of things are things that you've got to be able to deal with yourself. People that are employing you don't want to listen to this crap. If you'd have gone into your book and had any notion that your book addressed this and created the problem, if you'd have gone to page 23 and 24, there's a little thing right there that tells you exactly how to use Bose notation. All you got to do is look at it. Some of you take it as an excuse not to do it. That is not what employers want. They don't want excuses. They can get those anywhere for free. They don't need to pay you for them. Okay? So don't look at it as a way of getting out. It's an opportunity to learn. Go to the page, look at it. It tells you what to do. I told you to do it this way, so I will. Just label the joints. Okay? It's as simple as that. Those joints don't know that I labeled it A. I'll guarantee you that. You label it something that you want to use that keeps records. It has nothing to do with anything at all. If this is A or Z, it's still the same joint. Okay? So, take a look at the problem and use it as a learning opportunity instead of a way of getting an excuse to get out of work. That's not good. And it's a way people lose jobs. Okay? So let's go about it. I'm going to go through this step by step. This is a relatively difficult one as far as students are concerned. I'm going to take a look at it and I say, gosh, that looks like it's symmetrical. Then I look at the loading and I say, my heavens. Not only is it built the same, it's loaded the same. If it's built the same and loaded the same, what do? We add up all the loads and divide by 2, and we've got the reactions. So 500, 1,500, 2,500, 3,500, 4,000. 4,000 divided by 2 is 2,000. And if it's got a roller, it doesn't matter if it's a hinge and a roller here. Why doesn't it matter? Because there's no battered or horizontal forces. Their X's are all 0. So there's your picture, okay? Now we do a quick survey. We look and see, are there any joints that the forces are only at right angles? Where they come together like this, or like this, or like this. Are there any of those where we've got right angles? And I look at that thing and I say, heavens, no. Everything's got an angle. So I can't do anything by visual inspection. It's impossible because I don't have a way of taking this and changing it into 2 vectors in my head. So inspection's out. Now I got to start at a joint. And I look at it and say it's symmetrical. So do I start at A or E? Doesn't matter. I made a list right here. It's symmetrical. So this one and this one are the same, this one and this one, 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 and that one's a loner by itself. So all I'm going to do is calculate half of this. Looks like 3 joints and the problem's over. So I'm going to call this joint 1, call this joint 2, I'm going to call this joint 3. Which joint can I start at? Known, known, unknown, unknown. 2 unknowns. I can start there. Unknown, 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 known. 3 unknowns. Can't start there. Unknown, 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 unknown. 4 unknowns. Can't start there. I'm railroaded into a position where I can only start at one spot. I elected to use the left half. You like the right half, use it. Doesn't matter. So I'm going to take joint 1, and I'm going to draw it exactly the way it is And the book told you, or one of the videos told you, it says just assume positive for the first joint. So I'm just going to assume positive, or pulling it out. So I'm going to put this here, I'll put this there. And that has ends of AB, so this is AB. And it has ends of AG, so this is AG. I'm going to take and just add them up. There's joint 1. It's easy as summing x's and y's. So I go about doing it. Sum of the y's have to add up to 0. Minus 500 plus 2,000 plus ABY. ABY has to equal 0. That looks good to me. Okay, ABY. Now you got a choice. You either can draw a slope triangle or find the angle. Okay, I got slope triangle for this guy. If I ask you in the office, make me a cut list for each part in this truss, and I ask you how long is piece AB, how would you figure it? It's exactly the way you do this. So I'm going to do this. I'm going to take a little dotted line, drop a plumb bob right there, perpendicular, and I'm going to put a dimension right here. And that dimension is right there, 12.5. So if I wanted to figure out the length of AB, there's 1. And if it's 20 foot high and it's constructed the way it is, that means this is 10 foot high. That is not a guess. That's using mathematical logic to figure it out. I can prove that mathematically that that is 10. So my little triangles going in here is relatively simple. It's 12.5 by 10. And now I need is a diagonal. Okay, so if I wanted to get the angle, I could just take the arctangent of 10 over 12.5. And if I did that, this angle is actually, if you decide to use angles, I don't. That's about 38.66 degrees, okay? I use a slope triangle. If you use a slope triangle, you put 10 in your calculator, square it, 12.5 in your calculator and square it, and then take the square root, you get 16.008. So that's how I busted up AB. The y component is 10 over 16, the x component is 12.5 over 16. So I want y, so I want 10 over 16 minus 1,500. Plus 10 move the 15 to the other side, turns it into a positive, multiply by 16, divide by 10, and get 2401.2. Okay, my answer came out positive. The positive means that that arrow is right. So that's a good arrow. So I'm going to come over here. I'm going to put the arrow. Here it is. And remember in class we went over, they come in pairs, either pointing at each other or pointing away. And I'm going to put 2401.2. There's that one. Okay, the other one, sum of the forces in the x. Oh, none. AG is going to the right. ABX is going to the right. Looks like ABX I got, so I'm going to take AG equals minus ABX. And the x of that, horizontal, x over 16, so it's 12.5. Okay, so I do the math. I multiply by 12.5, I divide by 1608, and I get 1875. So AG is equal to minus 1875. What does the minus say? Excuse me. Yeah. I screwed something up. Where did I mess it up? Let me look at my notes. I got it figured out here. Let's see, 2,000, that's good. Oh, I see what I did. This is actually a minus 1,500 on this side. So this should have been a minus, which makes that no good. Excuse me, I should follow my notes. If that goes that way, then this over here becomes exactly right. These become positives. Okay, sorry. The numbers are right. Minus 500 plus 2,000. I was going that way, so it's a plus ABY. If I combine these two together, it comes up to positive 1,500. 1,500 is a positive here. If you move it to the other side, it becomes a negative. So the answer is negative, which reverses the sign. That makes that good. And when I put it in like that, AG is going to the right, ABX is going to the left. Add it up, you end up with the 1875. So my arrows should look like this. Excuse me, excuse me. And of course, they're the same on the other side. So there's two of them. Now, have I got myself in a better spot with joint 2 or 3? Known, unknown, unknown, known. I can do it. Known, unknown, unknown, unknown. 3 unknowns, can't do it. So, I take and I erase this guy, and I draw the next joint. The next joint is this guy. So he's going up like this on an angle. And he's got one going down here at an angle. And he's got one right here at up and down. And he's got this arrow going this way. And it's got letters of BC here. It's got letters of BG here. And this is joint 2. Okay, how am I going to mess with this one? Let's see what we can do with it. Make sure I get my signs right. I'm going to use my paper. Okay, I put the arrows on this one. Hopefully you realize that if this is one member, the sense has to remain constant. So this guy's in compression, so this guy needs to be in compression also. If you don't put them in however you think, it's going to wash. Put that one that way. And I don't have a clue on this other one, and I decided to make it this way. I'm just putting the arrow in. Don't sit there and think about it the rest of your life. Okay, this one I already figured out. That's the same up here. It's the same angle, so it's the same slope triangle. Now I've got that other one. It looks to me, it's right here. So it's 10 high, and it's 1666 minus 12.5 wide. So that little triangle looks like this to me anyways. Okay, and when I did this, I came up with 10.833. So there's my two slopes. Now all I do is do the math, and I did it this way. Sum of the forces in the y, I have to add up to 0. I got a minus 1,000 right off the bat. Takes care of that guy. And I got 3 more to mess with. It looks like I got 2401.10. That's going up. 2401.2 times the vertical, which is 10 over 16.008. Takes care of this one. Then I've got what? I've got BC going down, so that's going to be minus BC, and that's going down. And then I got BG, and that's going down. Down 10 over. There's one of them. And I did the math on that top one. And what did I get? I got 5. Let me do the math quick. I've got 10 divided by 16.008. And I got that number, and I'm going to multiply it times 2401.2. 1,500. So this guy right here is 1,500. So the net of those two is positive 500. So I came up with an equation, okay? And you can check it and make sure it's right. The equation for this guy turned out to be the following. That was my equation. I combined. These two combined for 500. I left them on this side. I moved those two to the other side and then flipped it. Then I took 10 and divided it by 16 and got this one. Then I take